All right. Okay. Okay. So welcome, everybody. This is the start of an introduction series about data science. We are actually offering this every semester from the core labs. It's part of the trainings that we offer every semester. So first of all, I am part of the KVL, the Chaos Visualization Lab here in Core Labs. These are my colleagues and my staff. And let me tell you a little bit about myself. I am not a computational scientist by training. I am actually a biochemist. So as many of you might be wondering how this happened. Well, I also love computers and I fell in love with programming. But set that apart, we offer also a lot of resources for you that you can visit in this website for KAUST people. You can enter and check it out. There's a list of trainings that we offer. There is different topics like visualization with other software. There is the data science tools. And for example, we have there one of the best examples that I like you also to check it out is the YouTube channel that we offer, where we put all these different trainings that we offer. So by the way, this training is actually recorded, so you can check it out later if you want, once I upload it. Okay, so let's start with what is shell? And as you might see, as confused as my fellow here in the picture, shell is a strange name for something in a computer. But what is it? It's a command line, CLI. This interface is basically the thing that mediates you talking to the computer. This is why it's called shell, because it's protecting the actual language that the computer talks. You all know, pretty much you know the joke that computers talk in binary. So you cannot talk binary natively. We use another set of languages. So in order to mediate this communication, we need something, and that something is actually the shell. It's been around for a long, long time. As a matter of fact, I remember my first video games being like with a black or blue screen. And since then, it hasn't changed because it's that stable and that efficient. And it has its own set of commands. If you master them, then you can become really proficient and doing things super quick. So I'm going to tell you just some basics, but it can be as deep as you want. Okay. So why would you want to actually learn shell? Well, for starters, and that has happened to me, I look like a hacker. Even though I lost all my hair, but I do look like a hacker when somebody that doesn't know this say like, what are you doing? And they get confused and they go, it's awesome. It's like, oh, you can do all these things. And then it's like, yeah, Matrix, you know, Neo and stuff like that. So that's one thing. But the real thing that you must be actually worried about is that the most powerful supercomputers in the world run on Linux. Sorry, Windows. As a matter of fact, Linux is that powerful that Windows has now something that is emulating Linux, which is called WLS. Why? Because it's powerful. It's super easy to understand also, and it makes everything super easy to just process. So that said, if you want to use, for example, the supercomputers we have here at KAUST, you have to learn Linux, or at least shell, to talk to them and to use them. Before that, you can do anything, nothing. Okay. So this material here is actually based, and we're going to use it, is based on the material of the Carpentries. The Carpentries is an international organization that it basically has done workshops even in Antarctica. This material is going to be open for you to check it out in your own time. If you feel like there is some gap between it, you can review the things. So we're going to do that. I am actually certified by these guys as an instructor. So that tells you nothing because probably I don't know what I'm doing. So let's keep on going. So what I want you to understand is these 5 points. We're going to go through all of them. Hopefully, you will not get lost that much. But the first things that you have to understand is how to navigate using only a black screen. And then you will probably need to create things, create folders, directories, and so on. And you have to go up and down in this part. The pipes and filters are actually where the real good starts, because you can actually combine things to do something more useful. And the two last parts, the loops and finding things, the loops are a little bit complicated always in any programming language. But as a matter of fact, it's a very powerful tool to use. And then obviously you want to find something, but to find something usually in your Macs or in your laptops for Windows, you have something that search for it. How do you do that in a black screen with only one line? That's something different. But you will find that that is also very easy. Okay, so most of you or all of you should have read already the requirements that I sent you in an email, that if you didn't have something, especially the Windows users, that is a terminal, then please install these things before coming here or opening a GitHub account. It was in the email, it was in the web page, it was everywhere where I could put it. And well, Mac users and Linux users, if there's a Linux user, please raise your hand. Okay, so you don't need anything, you already have terminals, right? So in that sense, allow me to start first a little bit with the web page. In the web page, there are several things that I like to highlight. The first one is the one that is a curriculum. That hyperlink is going to take you to the material. If you click there, it's going to open a new web page where is all the material we're going to be reviewing. Then this big square here of the class GitHub is something for KAUST people. These are resources from IT that you have at your disposal. They are actually something that you can just click and start, and it will give you some terminal to use, okay? That's if you didn't install anything in your computer. Now, for people in Zoom that is from the country, you know, from outside KAUST, I have this resource here, which is also a resource that is public, but is very limited. So hopefully not more than 10 of you need it, because after all, it's something that is public, so it's not that powerful. Okay, so for those of you that are going to follow me, I'm going to use something that's called Class Hub that we have here in KAUST. Tell your teachers about it, because this can be actually useful for everybody. Well, I will sign in with GitHub. A couple of you write to me with the GitHub account, so you can use this resource. We're going to spin something that is basically a Docker image. Let's say a self-contained program that is going to allows us to use a terminal. Okay, for those that are nodding here, well, as a last resource for KAUST people and also for people from outside, I put a link there, and it's basically the same thing. You go to a repository in GitHub, then you can click where it says Launch Binder. You can see there the red square here. You click there, and it will launch this resource. However, like I said, it's very limited, so hopefully you don't have to use it. But in case you have to use it, just click there, and it shall start now. Okay, in that case, you should always try to look for something that says terminal, that has that symbol, that black square here. And we can start the lesson. But before starting the lesson, there is something that I want everybody to use actually. Go and click, please, where in the web page says collaborative notes. In those collaborative notes, it's going to take you to something that is called Etherpad. That resource is a cloud resource where we can take notes for everybody. They're going to be open. You can change even your name. If you don't want to be, I don't know, Didier, like me, You can change your name to LeBron James, or I don't know, Michael Jordan, something like that. It's a very good resource in case if you are shy. Also, it will let you ask questions and chat with us anonymously. So don't worry about. You can put there any question. Because we are too many, and we are too many here and in Zoom, please spin something like BART or OpenAI ChatGPT. So it will be your assistant for this specific task. And in case you feel like you're left behind or you have another interest, then you can ask your your AI assistant, how it's called now, and obviously it can help us also to fast forward these lessons. Okay. So in that sense, if you see this part here, I'm going to begin this course here. I am already in this thing, so it will take a little bit, but not that long. Meanwhile, anybody can go to the Etherpad. You're here, please, in the Etherpad. I do need for you to put some mark here in this question because I need to really know who is here. We had many submissions, but I don't know who's really attending. So I need numbers for you, for us. And like I said, here in the chat, if you don't want to be you, you can be, I don't know, Elon Musk. And then you start chatting as Elon Musk. Anyway. Go down. And also, I would like to know your preference. If you are like, these kind of things in the morning or these kind of things in the evening. I am more like an evening person, but not everybody is like that. So that's for sure. Okay, so now I'm going to spin a new terminal here. And there it is, a big black box. This is where your journey begins, okay? Now, everybody already has a terminal to use? Everybody set? Okay, we wait a little bit. Okay, go down. For the Jupyter Hub, when you are here in this one or in the binder? Okay. So go back. Were you in this one or in this one? Okay. In the link of the Jupyter Hub of IT. You mean this one here? So this one? Okay. The catch with this one is that you have to ask IT usually for permission to enter. And this also is a limited resource, but try it. Put your user and your password, the one that you use in your terminal. As long as you have a terminal, it's okay. Like in this one, for example, if you can use something like this terminal here, it's okay. In this site, the one that you use in your portal in KAUST, your IT credentials. But like I said, I put it on the email. You probably should have asked IT for permission beforehand. All right. So at least we can start with some concept. For all of you that love and thrive in the Windows system, you probably are familiar with those paths. The path is like, where is my documents? Where are my files? Where are the things? In Linux, it's pretty much the same. If you see this schema here, it actually tells the whole story about paths. Now, what is important here is where are you situated? This is important when you are like in a very big cluster with 100 different users, and then you have access to your stuff, but not everybody's. So in this case, if you see here, the parent thing here is just a slash. And that slash is actually the opposite slash of Windows. It's in the other sense. And that is what we call root. It's the root of the whole system. Nobody should touch the root, because if not, the computer just dies. From there, it can branch out to different things. Like, for example, you have, in this example, a folder of data, a folder for binaries. That means basically executables, and some temporary folder that it could be for just storing things for a very small amount of time. And from, for example, the folder users, you can span 3 more. Like a user can have its own folder. So in the page here, you see that in the bottom I have already one of the commands that I want to show you, which is ls. What does ls do? ls stands for list. And that list is going to, in theory, tell you what is where you are. So for example, if we type ls, you will see something different for you. I have these 3 things. 1, 2, 3. I don't know what they are, but they are there. So ls have, and many actually, I should say, like all the commands in Linux have actually a manual that you can read of. And usually they also have something called --help. With --help, you have all the options that you can use with ls. So ls can do a lot of things as long as you tell it to do it. So fast forward, for example, I'm going to give you one of my favorite commands, which is ls -altr. But it's already getting a little bit clunky here, right? You cannot really see what's going on. So there is a very clever command that is called clear, and it will clear your terminal. So one of the things about Linux is that it's going to save all the things that you have done previously in a history. So if you type just with the arrow up, you will get just the last thing you did. If you go again up, you will be the almost last. So to exemplify that, actually, there is another command called history. Here you have all the list of histories, all the list of commands that I have done in the past 102 lines. You can see here, for example, in the number 100, I have the one that I like, ls -altr. And again, I have a very small list, but this list is now sorted. It's very different to do just ls. So ls -altr is something that is going to be very useful for you in the following sense. You have your command, which is ls, and your option, and then an argument, which is what do you want to read on. But the options here are actually combinable, and there are a lot of them. In this case, that's just -help. Oh, yes. If I go and search for -t, it will tell me, okay, you sorted by time. You see? for the newest first. If I go and search for -R, there is two R's. There is capital R and the other R, which is in reverse. Okay, so I can combine those two. If I go and search for L, not the capital L, use a long list format. So ls minus ltr give me a list. Here. It gives me a list of things that are in where I am, sorted by time, but in reverse. That means that the most recent one goes to the bottom. This one is very helpful because sometimes you want to just find what is the newest thing in your folder. Now, one question is like, how do I know where I am? There is another good command that is called print working directory. That will actually tell you, you are in this part here. Okay? And if we go back to the concept of paths, you will see that, okay, this is your root. Then you went to folder home. Then in folder home, you went to Jovian, which is your user folder. Okay? So I'm working here. This is where I'm right now. If I do ls that thing, this is where I am. Okay. So I have here three things. If I do -f, I can know now that it's going to do a slash, and it's going to identify them as a folder. Okay? These things will come naturally to you with practice. But so far, just remember, ls minus ltr, that's one thing that you want to do. Now, what happens if I want to go inside of a folder? Well, there is another command that is very easy to remember, which is change directory, or cd. If I want to cd into this directory here, the KBL binder serve, I just try to write it. But I'm too lazy. So Linux, what actually does, if you put, let's say, 1 or 2 characters, and then you press tab, it auto-completes for you the thing. So you don't need to write the whole thing. You just have to give Linux like a couple of characters, then you press tab, and it will auto-complete. And this was done way before iPhones were outside. It's been forever a feature of Linux. So in this case, I'm going to change directory. I'm going to go inside KBL binder serve folder. Now, when I press, nothing really happens, except that, well, it changed a little bit here. Now it's telling me, OK, you are inside of that folder. Fine. I'm inside of that folder. Now what? What should I do? First thing, I will clear this. And then I can do, OK, ls minus ltr. And now I can see I have many more things there. Now, these things here are a couple of things I wrote just for this specific class. But this is something that I still don't identify. If I put an F at the end, then I can see that there is one folder among all the files that I have here sorted. That one is the one that is called shell lesson data. OK? Now, in that, I can go in. I can go deeper, right? Now I am going deeper and deeper and deeper in the folders that I have in my system. So far, if I do, again, pwd, now it will tell me, OK, now you're not only in home, Jovian, KBL binder, you enter also shell lesson. So you're going deeper and deeper and deeper. That's a good way to go deeper, but how do I go back, right? What if I'm in the wrong folder or I want to just go to another folder? OK. This is where the concept of what is ... means. To go one level up, you can do cd ... and it will take you up. So if I print again the directory where I am. The difference is like I went back one level. Now, there are other couple of tricks. For example, if I do cd minus, it will take me back to the previous folder where I was. Meaning, if I go completely out of here, and by just typing cd, I do print working directory, I went back to my home folder, where the system puts me at the beginning. But if I want to go back where I wanted, where I was, cd minus will take me again all the way down where I was. Or it can just jump all over the place. It depends on you. How fast do you want to go? You can go really, really deep. Or you can do also something really explicit like dot dot slash dot dot slash dot dot. And it will take me to home. The dot dot notation takes you one level up, okay? Always. Now, if you use only one dot, that means here for Linux. When you use instead cd dot, it will not move you. It will be just standing right in the same place. Case in point, cd dot. Okay, I didn't move. So the dot signifies here for Linux. Okay? Now, right now we can either take a 5-minute break if you want to get some coffee, clarify your ideas, and download the material. Because if you went to the website and the curriculum in the website, it says that you have to download something. Do you have it downloaded? I don't think so. So please go back to this page, web page, the Unix shell, and you will see that you can, one more previous here, in summary and setup, there is shell lesson dataset here, okay? Download that one. This is the one that you are going to work with, and we're going to work with it, okay? If you have it already there, well, go get some coffee, some cookies for you. Okay. Chat. Whoa. Yes. Tell me. Come. Tell me. Oh, watch out.
So,
Yeah.
It was, I started doing this earlier today at the lunch break, and I didn't quite finish up. But I downloaded the WSL,
Okay.
to the updated version, moved into the Kali Linux and all of that, then the VS Code, and then I only got to this point, and then I don't know what I was supposed to do after this. Didn't finish the video. Maybe you could.
Oh, you follow my friend Abdul Raful.
Right, yeah.
Okay. Actually, if you install this one, if it's already installed,
Yeah.
you can type terminal here.
Okay.
Oh. Okay. He doesn't like it. Give me the terminal. Okay. Then here, terminal, new terminal. And you have it here. This is your new terminal here. Okay. But we have to change from PowerShell to, where is, there should be a way. In PowerShell, it should be different. Okay. It should allow to actually do it, but this is Windows.
Right. So
if not,
so I do have the other one here though. This is the Ubuntu one.
Ah, excellent.
Right.
You can work in
I
that
can
one.
just work in this one over here.
Yes.
Okay. And then that document.
In the web page, in the registration.
Okay, so here.
Go to this one.
Okay.
Go down. And you have here collaborative notes. There.
Right here. Okay.
Yeah.
And then the other one. Okay, so this is the other. What was the notes that you had just pointed out?
They're
The
notes is here in
software carpentry.
curriculum.
Okay,
This one.
so,
Yep.
gotcha. Thank you.
Yeah.
I have an issue.
Yes.
So mine is Windows Mission. So I try to open this task up, but Jupyter is not opening. It's showing that.
Did you have a GitHub account?
Yeah, I have a GitHub account.
You have to pass it to me so I can pass it to the administrator so you can get into the list.
Okay.
But
To your email address, the one you shared. Okay.
yeah, the one, yeah,
Okay.
that one.
Okay.
I'm logged out of my own computer. Excellent.
Okay, you only need my
The GitHub account.
Okay.
That's the thing that I need to send them to. They will send you an invite, and then you accept the invite, and then you can use it.
Okay. Okay, I will send.
Yeah.
Credential.
Yeah. Hello. What's up?
I'm not quite getting the same thing.
Because you're in Windows.
Yep, I went through Jupyter Notebook.
Yeah.
And opened it up in the terminal. I'm trying to kind of get into seeing something what you're seeing. I'm not quite sure what I'm doing wrong.
No, I mean, the thing is, this is a PowerShell. This is Windows system.
Okay.
So you're still not on the, you are still not on in a Unix system.
Okay.
So, well, I don't know. If you launch a terminal here, yeah, it launches the same thing. Can you try to use, for example, the Jupyter Hub? You KAUST.
Yeah, okay, I'll try it
Well,
for now.
Yep, it's one in one of the in the registration page. There is a link to it.
Okay.
Yeah.
Yeah.
Okay. You can use this one.
This one, right?
Yeah, it's the same. This one is a Mac. Yeah.
Okay.
Use this one. Yeah.
Okay, then.
It's okay.
Oh, okay.
I mean, like you can type all the commands that we hear, like type ls, for example.
Sure. Yeah. Okay.
Yeah.
I'm using the Linux also.
Great.
Kali Linux.
Uh-huh.
So I don't have any like directory, like any folders of anything.
Don't
I
worry.
can create it myself, but I got into the root. So how can go back to the home?
CD, enter.
Did you enter?
CD, enter.
Until I root.
You use sudo. That's strange. Okay, then home. No, it's because you are the master of this. So don't worry about it.
Okay, I'll try to fix it.
Yeah, just download the, right now, you just download the material of the class and it will have different material for you to just work with.
The access to
Yes, I usually you ask IT once and they activate all your credentials. I mean, I'm talking about the class hub, the Jupyter hub, the virtual machines. Yeah, but this is why you ask them usually. Yes.
So I'm not able to, and I already sent the email.
To these guys?
Mm-hmm.
Okay.
And how can I work like the other students? So I download this.
Excellent. Can you go to the registration page?
This one.
Mm-hmm. Okay, go down, 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 down. Click here. Now down. Click here.
This one?
Yes. Cross your fingers.
This one.
No, wait for it to. There you go. Okay. Now here you have a terminal.
Mhm.
Now you can upload your files here.
Oh,
Okay, and then you can. It's the same.
Okay.
Okay.
But I don't have any background information about.
Don't worry.
You don't. Oh. This
Yeah.
is fundamental.
Yes. This is basic. So as a matter of fact. Okay. Okay. Because everything in IT needs coffee. Oh. Okay, launch it again. Yes. Good. All right. So let's get back at it, okay? Like I was saying, there is something beautiful about this thing that it will just register everything you're done. And it's going to put numbers on it. So say that you want to do something and you're very lazy or you just have one hand because you broke your arm. Happened to me. So you can do exclamation point 111, for example, and that will tell him, hey, execute line 11 from my history, which is go to CD. And now it executed that. This command basically is telling like, hey, take from the list that you see there that you're storing something for me. For example, if I do the same, exclamation 95, it's going to do something that is called ls minus r, capital R. Now this one, I love this one because it's very powerful, because it's recursive. So in the sense that if you download something and you have a folder like this, where you don't know exactly where are your files or what are the names or whatever it contains, you can go recursively into it. And then it will just say, okay, so you're working here in shell data, and then it has exercise data, new file, Pacific, North Pacific jar. But then shell also has these other exercise data alkanes, and inside it has these different files, and so on and so forth. So you can quickly, with one single line, you can see inside of all the folders that are in that folder. I just went and checked it out, and it's like, okay, so maybe I would like to see what the hell is that unicorn.dat. I don't know. I like the unicorns, why not? So how do I go all the way there? Anyone wants to answer the question? What can I do to go all the way and just stay there where unicorn.dat lives? Where the unicorns live, or the monsters. So what would you do? What's the command to change directory all the way there? Could be. Let's see. For example, anyone else? Another idea? Going once.
Let's add file path on go, or we can do it. Right?
Exactly, yeah. Exactly, you can use the complete path, or you can do, like here the colleague said, iteratively. You go inside one, and then inside two, and so on. So in that case, I can type cd, and then creatures. Okay, now if I do pwd, yes, I am in creatures, perfect. If I do ls minus ltr, okay, I can see that there are 3 files there: Unicorn, Minotaur, and Basilisk. Okay, so if you're not Harry Potter, you don't care about the Basilisk, which is good. But here comes the question: how do you see inside of one of these things? You cannot use Word. You cannot use Notepad. What can you do to see what's inside of this thing? You can use an editor, for example. Now, here it comes a very tricky part. Word is fabulous, you know? I have to admit it. I like to work in Word, even though I don't like Windows, but Word is fabulous to do stuff. In this setting, in the terminal, you have a very limited thing that is called text editors. And how the name suggests, it only edits text, not figures, not graph, no nothing. It will just display characters in your terminal. It's very limited. And there are different flavors of it. There is one flavor that is called Nano, which is very basic. There is one that is very powerful, but very difficult to master, which is Emacs or Beam. As a matter of fact, I'm going to tell you one of those stories, horror stories that happen when you start this path. If you type just BI, it takes you to this thing. Now, in this script, pretty much everybody frozen because it's like, aha, what the hell do I do now? How do I exit Beam? It's one of those computer jokes that you will encounter at some point, because there is many people that has just froze here and never got out. So, because that is kind of complicated, we can use one thing that is called Nano. If you type Nano and say Basilisk, you can see inside the Basilisk. Okay, and this is why I meant by text editor. This text is basically only text. If you see from here to there, for those of you that come from the biological background, this is a sequence, correct? Maybe it's not the best sequence in the world, but then, you know, this is the Basilisk sequence. Okay. So in order to get outside again, usually you have a very nice X in your window, right? You just go and click and it tells you, hey, do you want to save? Hey, do you want to do something before I close this? Correct? Here, that doesn't happen. Here, as a matter of fact, if you see my cursor is right now in common, and I can edit it, and I can type whatever I want, but I cannot get out unless I know how to get out. In the bottom, as you can see here, in this bottom here, there are actual commands that you can use, okay? So the tricky part is to know how to read, because many people doesn't know what's that thing next to the O on next to the X. That one, my friends, is usually control. In this case, Control X will take you out, but it will nicely ask, hey, do you want to keep these modifications? You can say no, and it will go out, and you're back into your screen, okay? Yes, I know this is not a perfect thing. Yes, I know there are way better things. Notepad is better, for example. Even there are other like power nodes that they are better, sure, but they are not in your system. Surely they are not in my system now, okay? So there is that one. We can see inside something. Now, let's do the next exercise. We're going to create one other fabulous creature. What do you like? I don't know. I like the Pegasus, but that's because something in my childhood. But just one mythical creature. I know, from India. One mythical creature from India. I'm seeing. Okay. Okay. Can you write it in the notepad? Okay. Give it to me here so I can create a file that's called like that. Okay. Ah, didn't understand. Okay. So, but you did. You. Did you understand the question? Give me a creature. Any creature, whatever. A horse. Okay. The mythical creature horse. Fine. So how do we create mythical creature horse? Very easy. Nano horse dot dat. Okay. Now I want you to write something on it. Okay. Let's write anything. You do and do that. I mean, I know how to do it, but now you go and create horse and now write something on it. Then I will tell you how to save it. Let's say, okay, the horses are pink in my mind. Okay. Ready? Try to save it. How would you save this? Because, you know, it's in there, but it's difficult, as a matter of fact, to pick up. That would be good, exactly. Ah, okay. Oh. Save the modifier. Okay. Yes. Let's see. Okay. Now we created a horse. Okay. Nano horse. That is that. Excellent. Now you can actually overwrite things if you want to keep saying like, horses are tall. You can also use Control-O to add to this thing. Then it will tell them, hey, the file name to write is horse that. Should I write here in horse that? And then you just press enter. And it says, I wrote 2 lines in horse that. Okay? And then you exit. Okay? Yes, tell me.
What name to write horse that? And don't find anything.
Well,
Do you mean cancel source format, Mac format, append, defend, backup file?
when that, did you press enter when you find that one? Press enter. Okay, what happened? Everything.
I'm in the nano. I am a horse.
You have a horse. Congratulations. Okay. So we have that one. Correct. There is more than one way to visualize things inside of a file. Let's say you don't want to use Nano because you don't want to, I don't know, fall asleep in your keyboard and, you know, mess up whatever is inside of your file. Okay. So we can just inspect something. Like, let's say, okay, I just don't need to see the whole thing. Let's say I want to see just the first 5 or 10 lines. Okay, there is one command that is called head. Guess what head does? Exactly. It just shows you an amount of different lines that that file has. For example, I did head here with basilisk that. It just tells him, hey, just give me back 10 lines of basilisk.dat. And it shows in the screen. Okay? Can I ask for more? What do you think? Can I ask for more? Let's say I want 15 lines. Could be head, one. Or, for example, you can do that's just help. Okay? When you do that's just help, then you access all the different material that it has inside. You have, for example, -n says print the first number of lines instead of the first 10. Okay? So if you have, let's say, you need to check the first 15. Head -n 15 basilisk. Then I got 15 lines back. Okay. Now let's say your information is not in the top, it's in the bottom of the file. Guess how creative the Linux programmers became. Imagine what the command that goes to the bottom it looks like. Almost foot. Tail. So that's just help. Here you will see tail, print the last 10 lines of each file. So if you want to go to the tail of the basilisk, tail basilisk that. Now I'm in the last 10 different lines. So you see, this is a way to inspect quickly very big files. Like I just want to see if this is the right one, see the header, or see whatever is in the last 10 lines, if it has the same thing or I don't know, the right wording. This is a very useful way. There is a fourth way that I actually use a lot, which is cat. Cat is actually for concatenating stuff. So it will basically put one file and then the other. He's going to just glue them together. But it will also deploy it in the terminal. If I do cat basilisk that, boom. It tells me, okay, this is all the sequence of the basilisk from top to bottom. If let's say I want to concatenate this with my mythical horse, then this is the last line of basilisk, and this is the one that I did for horse. Okay, so cat has these two options. You can use it to visualize what is inside of a file, or you can glue together two. Okay, so first question now. How do you think we can generate more files? Let's say not using Nano, how can you generate another file? Now, I think the guys that invented the one command I'm going to give you, they like it like MC Hammer, because now you can create files with a command that is called touch. Now, you can touch this, dot that, and then you have one thing called this dot that. Now, it should be really curious, this thing, because when I touch this, I created something called this dot that. But you can see it has nothing inside because it's marked here. This column here, this column here, it doesn't let me, okay. If you see this 0 here, it means it has nothing inside. I just created something, but it has nothing inside, okay? It just created an empty file, which is fine. Horse that, on the other way, it has my very beautiful poem about horses there, and it has something. This is why it has 49. And then unicorn, minotaur, and basilisk has all the sequence there. So you can see that there is like 1,800 different characters inside. So you can easily tell who is actually with information and who is not with information. Now, that said, let's start with something that I like, which is basically combine stuff. Now, say that you don't want just the first 20 lines. You want exactly from line 5 to line 10. From the 15 that you selected, from the 20 you selected from the very start of the file, you just want the last 5 of that. How do you do that? Okay, Linux is very powerful because you can combine the things together. So one of the ways to combine these things is with something called pipes. And the pipe symbol is basically this line is here. This This line here is just telling the computer, hey, you know, whatever happens here, pass it to the next one, and then process it. In that case, let's do it like this. Okay. So far, so good, right? This is what we have done. Yes. Tell me the question.
When we have the window terminal of Nano,
I
just want to go back.
Control X will take you out from Nano. Remember that one. Control X, enter twice. Okay. Let me clear this. Okay. So head minus N20 basilisk. Then when I use pipe, I can actually concatenate tail minus N5. If I do this, I get this. Now, what do you think I just did? Exactly. I took the last 5 from the first 20. So this is line 15, 16, 17, 18, 19, 20. This is a way you combine many things. You can actually combine them in different ways. For example, if I do, let's go all the way to home, and then let's do minus R tail. Okay? So for example, here, let's tell me, hey, I cannot open this, that's fine. I don't have the permissions to do that. That means it's not mine. That's fine. And then it tells me, okay, there are some things, there are some files here that I just saw, but this is the end of the list. This is not the complete list that I can get. Okay? If I do the same, but with head, it will just tell me like, okay, you just did this, but then, you know, you have these 3 files here, these 3 folders here, and so on and so forth. All right? So this is a way you can combine different things. For example, also, this is kind of redundant, but if you do head minus 30 basilisk, by the way, I have to tell you also how to navigate these things, because usually it takes a long, if you are writing like something like this, minus N, 30, blah, blah, then tail, then I don't know, sort or something like that. It takes you a lot of time to go back to the start of the line, except if you know how to just tell him go to the start of the line. But I will go back to that in a minute. Okay, so this one is like that, but if you do cat, I don't know, basilisk and horse, and then tail, it will give me basically back the concatenation of the 2, but the tail end of the concatenation of the 2. Anyway, so this is one way. Now, let's say that you want to save this. Let's say that you want to save something in particular about ls. For example, if you do, let's go back to my home and then to KBL here. Okay. One more time. Okay, clear. Nice. Now, let's say that I have this thing here, but I want to see what is inside here. I do ls minus r. How do I save this into a file? Should I copy paste this into Nano? That's one. You can pipe it, for example. As a matter of fact, there is one thing that is called redirect, which is basically you put a sign. There's a, how is it called? The crocodile eats the other way. Greater than. And then let's say folder .txt, and it's pretty much looks like I did nothing. But what I actually did was to generate folder.txt. If I go inside of that, then I just save the output of that command. Okay? So this redirection is actually important. Why? Because you can generate whatever you want and save it at the same time. There are super convoluted ways to use it, but it's also very quick because you can go very quickly into the folders, see what is in there, save it into one of the files, or you can use another kind of commands. For example, let's do something. Of course. So let's go to alkanes. Okay. Now, this is two new commands that this is going to be your exercise. There are two commands. One that is called word count. Word count wildcard.pdb will get you this, okay? And there is another one that you're going to use right now that is called sort. But now, who wants to tell me what I just did? Because this is easy. What is word count doing? Yeah, it's just counting words. And then the output is actually very nice because you have lines, you have the number of characters, and you have also the number of, I always fail to remember that one. Words, yes. Words, characters, and lines. This is the significance of these three different columns. Okay, now, if we do something like this, sort, let's take it one step at a time. Sort dash help. Okay. Sort basically is going to do that. Sort things by certain characteristic that you give. Now, what I want you to do is use that word count with that asterisk.pdb, then pipe, and then try to sort these numbers. Okay? So I will give you some minutes to read this, to read basically all the flags that you can use with sort, and try to sort basically word count from, I don't know, the highest to the lowest. How about that? All right. Let's say some 5 minutes, and then we can take a break. So remember, you can do word count, wildcard.pdb, and it will get you this. But now you have to sort this. This is your task right now. crap. Uy. Interesting. So in case you're always lost, you can resort to this. That's accurate, actually. You can use word like the word count like this and use it with pipe. Okay, so this is why I was actually asking you to use BART or ChatGPT. So this one, I like this one. I like more this one, because it's going to be a very good example of something. Now, oops, have to load again. Okay. So let's say let's reapply something that BART just gave me. Okay. So you probably reach something like this, correct? Word count, something, then pipe, then sort. This will sort actually what the word count is going to give as an output. Now, a very good question is this correct? Because what I'm thinking that I'm telling the terminal is, hey, word count all the PDB files that I have here. That's the first command. Then I want you to use my output and sort it by the column number 2. So column number 2, it is sorted, but not correct. So there is a catch here. It is the correct use, yes, but it's not taking into account that you need the number to sort it by number. So in this case, for example, it's just going to sort by the first column. You see? But there is just one flag that was missing, which is the N that tells sort, hey, this is a number. So if the number is missing, then I cannot tell him, hey, by column number 2. And then we have the correct sorting. You see, that's the thing with AI assistants. They have a pretty good idea of what you have to do, but you have to check the answer. It is correct. You can use word count like that. You sort if you have letters. But if you have numbers, you have to add something extra, okay? Now, let's say that you want to keep this as a reminder of what is what, or what has what. Then you can save it into, I don't know, sorted.txt, sorted1, column number 2. Now this is a pretty good moment to tell you about names. What is in a name? So, as you might be familiar, you can save pretty much any name, any file with any name in the Windows system, in Linux system, in whatever system. And many people uses spaces between names, right? That's a no-no in Linux, in the command line, because it becomes really difficult to manage them. So instead of using spaces, use hyphens or use underscores, so your life doesn't become hell. Why? Because if you do something like this, sorted column is going to give you error. It's like, hey, what the hell is column 2? Exactly. It will actually do something like you need a slash to escape the character. This is the correct word, like to escape the character, you need a slash. But anyway, if you're going to use Linux, you can put the clearest name that you want. Like, this file makes my life happy, but each space, please put an underscore or a hyphen. Because if not, it's going to be really difficult to manage at the end of the day. Like you see here, it created sorted, but not sorted by column 2. So if we go and we say, hey, what is in sorted? There is nothing. Cat sorted underscore, and there is something. So the names are pretty much standard in that sense in Linux, like they either have hyphen or underscore, and then this is how you can work with them. Otherwise, it's going to be very difficult. Another example of that, of the names. Let's say that you want to do, we have seen so far how to do files, different files. You either basically put the output in a file, you touch them, that sounds weird, or you can use nano to create them, right? Now, if you want to do something like, I don't know, use thesis folder, right? You can do very ingeniously, make directory thesis. So now, you see, I have a folder called thesis. The thesis folder is empty right now. You can say touch thesis version final.txt and thesis final.txt, because, you know, academia. Now here I have now 2 files, right? I can create them, I can do whatever I want. But if I try to do, for example, just the same thing, but with make dir, and instead of this, I put this with the spaces. Let's say I'm going to try to create more directories. Now the -p is actually a good thing to have always, because it will prevent to create like many directories under the same directory, but it will preserve those directories that are already there. Just believe me, make dir -p is the way that you want to use it. Now here, it created everything, perfect. But if we use it here, because I have the different names separated by a space, now I have 3 folders. One is called thesis, one is called final.txt, the other one is called final. And this is because I just don't put this between the name. So names are important. Remember that one, especially for this. It's going to be important for you to have like a very clear understanding. And you can create as many as you want. Well, as many files as you can in your disk drive. So now let's start talking about something really scary, removing. So in pretty much all the systems, you can remove and it goes to a trash bin, correct? What's up?
Yeah,
You created more than one thesis, I know.
I cannot see when I write the command,
Mm-hmm.
the commands are not visible, but I just see as a text.
You see?
Commands as a text in my terminal.
Okay.
Those commands are not
They are not executed. You're meaning like something like when you do something like hit, like this, and then it just stays there. That's a good one. How do you escape that situation? It's a very good one to know. There is Control C or Control D. It should take you out of those. Okay, those are ways to escape. Not the thesis, but the terminal. Okay, so like I was saying, removing stuff here is very dangerous because you don't have a trash bin. So when you use remove in the terminal, be careful because one is deleted, one is gone. Okay, so if you delete something, let's say I remove my thesis, which I didn't, luckily. If I do this, if I remove the thesis, is gone. Everything that it contains is gone. I cannot retrieve it from anywhere. So choose correctly what you're going to remove or do a backup before you remove something. As a matter of fact, please do backup, especially if it's your thesis. Now, okay, so the actual command to remove stuff is very simple, is rm, and then you have a file, let's say sorted. If you do this, it kills sorted and it's gone forever, okay? But if you want to remove a folder, then you have to add rm minus recursive and then the name of the folder. Once you hit enter, and if it's not backup, it's gone. I cannot stress how important this is because people will cry, okay? So be careful. Do not delete things that you don't want to delete. Copy them and then maybe delete them. Okay, so for example, I want sorted column gone. Perfect. Nice and easy. Okay. So far, so good. What time is it? Okay. Time for a break. Okay, let's go get some coffee, some cookies. Go ahead. Rest. Before we continue with the next part, I do want you to honor a great tradition in the computer science. So please try to do this. Follow one line by one line, because this is very important. This is the first thing you usually do when you try to do a script. You try to make it print hello world. This has been like this since ancient times, more ancient than me. Okay, Steve Rogers. So everybody run the 3 lines? Okay, what's the outcome of the first one? Just hello world outside of the box, right? Now the second one, you can explain it to me, correct? Because now you have already seen that using the greater than, it just redirects whatever echo says to hello.sh. And then the third line actually is how you execute scripts for bash. Now, in an international way of convenience, all the scripts or mini programs, if you want to call them one or the other, is the same. For bash, they end up in .sh. For Python, they end up in .py and so on and so forth. It's like .doc. So that one is for documents, right? So there is a convenience in that because it identifies, and many systems already identify like, hey, this is a bash script. I should color it somehow. So that's a good one. Now that you have written your first program in bash, we can go hard into it. All right. So and with that, we are going to enter loops. Okay. First and foremost, it dies every time. Okay. Let's clear this so it becomes clear what we're going to do. Now, loops. Let's say we are still here. We are still in what is called data alkanes. So I have different alkanes here, and I want to do something about it. Let's say that you are going to write a script that only takes like, I don't know, the line 15, 16, 17, and 18, and 20, like we did already. You're going to pipe something into a new file. Now, you can do that every single line, right? What is the command to just get line 15 to 20? We already did it. It's head, then propane, then tail. As a matter of fact, it's like this. And tail and 5, correct? So you can do this one by one by one. And you can do this because one by one in this one is 6 files. But what if you have 6,000 files? What if you have 6 million? Will you go one by one typing this every time? Of course not. Like, why? I mean, either you're a postdoc, a very well postdoc to do this, or you can just write a bash script and do it in one line. Well, not in one line, but you create a bash script. So let's start with that bash script. Let's create it with Nano. Nano, let's call it middle.sh. Okay. Now, what is the syntax for loops? There are different types of loops. In any language, any programming language, you will find that there are ways to do loops, going iteratively over the whole thing that you have to just analyze. Okay. In this case, we're going to use only the one that I know that you can control the most because it's called for. So for has a syntax like this: for element in the list of things, then you can put the semicolon, and then the keyword here is do. You want it to do something, right? Now, you do that something, and then you tell it, stop the loop. Okay, this is the syntax. This gives you actually a lot of control because it will tell it like you start here, you end up here. There are other ways of doing loops that are actually infinite loops, that there is no clear way when they end, and then you get stuck in it. But for is one of the most reliable ones because you just stop there. Okay. Now, this is just the archetype of things. And we can do it here in the command line. For example, let's start with 4. Let's call it element in. And now you can apply something that I already mentioned, but it is a wildcard. This wildcard means everything. It's an asterisk, means everything. And then PDB, any character dot PDB. Okay. In this stage, you can press enter. And it opens again this thing here, which is a greater than. But that greater than doesn't mean that it's going to redirect. It's just entering inside of the syntax of the loop. It's like, okay, here, we start here. Okay, now you tell him, do. What do we do? Okay, let's do head minus n. And in this case, you have to do something that is called call the variable. Now, you see here, I put a $sign before the name element. This is basically to tell the for loop, hey, here, I am calling that thing element that is in the list here, right now. So, as a matter of fact, for me, the most beautiful way to write it is using curly braces. Element. This is for convenience because it accentuates that I am calling that variable element, even though I'm going element in all the list of the loop. Okay, and then done. Once I type done and I type enter, this works. Okay. So it just activates the whole thing. It's just like I was saying. Well, I didn't cancel exit. No, thank you. Okay. So like I said, the syntax is very simple. It's like element in list, do something, and then stop. Okay. You can even take this thing here. It's not needed right now. Control exit. Yes. Okay. So one more time. As a matter of fact, let's do it more explicit this time. For element in Octane. Have anything here with ethane, cubane, methane, and propane. Okay. I am saying explicitly, this is my list. Okay, I'm going by one the elements of my list. Then I press enter. Let's do again head. And now I call my variable element. That's correct. I am actually missing one step, which is do. Without do, the for loop is not going to enter. Now, if I don't do that and I get stuck here, how do I escape? With Control C or Control Z or Control C. Okay. If I, let's say something like I was saying, hit something and then it's not going to work. Okay, he doesn't like it. but good. Let's go back to the right example. So do head minus n 20. Now element. And done. All right. Because these are very short and very small files, I actually can see that this is compound is methane, this is pentane, and if you go up, 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 you will see the contents of everything. Okay. Now, let's say, or better yet, let's do the following. Your exercise is to do this kind of script right now. You're going to ask for line number 3, 4, 5, and try to divert it or create a new file that says middle something. Okay? Yeah. We're good in time, so you can play around. Try to do a for loop, a bash script, basically just changing these lines here. Now, in that something, ask for basically lines 3, 4, 5 of all the list. Let's see how much do you remember about these last 5 minutes. Okay. I guess you had enough time to confuse yourselves. So here, somebody has like a good answer that I want to share in the notepad? Like here with everybody. Exit. Yes. Okay. By the way, one of the things that it should be also a good practice that you always do, when you're naming a variable or that thing or element in the loop, put something very, very, very clear that everybody can understand. Because many of the times people goes like, for x in, I don't know, this. So x can be whatever, like in many, many, many different disciplines. It can be a variable, or it can be literally a letter, or it can be different things. And there is no actual limit into say like, okay, files with PDB. Yes, it's longer. Yes, it could be a little bit more work, but it's very clear. Like I am using this variable here. And the longer your script goes, the more you need to use these kind of things, because if you do 2 loops in a row, and one is x and the other one is x, basically you're telling it's the same thing every time to the computer. So you can be specific. Please be specific. .pdb. So in this case, what did you do? Head how many? To get just the 2, 3, 4 lines. How many? 5. Okay, good. Files with PDB, and then pipe. How many I have to tell? Like just 2 or 3, right? Then done. And it just came back with the list of the number 2, 3, 4 of each of the files. Okay? It just mashes it into it. You can do one arrow up, and then you will see that your for loop is all compressed in one line. Okay? If you master this one line, that's a lot of work to save, but it gets complicated with the more things you have to add. Right? We add here 2 things. If you have to add several lines, it's not going to be easy. As a matter of fact, if we run something like this, it becomes pretty much difficult to read, correct? Now, what's going to happen here? I'm going to create for each of the files that is going into the list of the loop, a new file that's going to contain only the 3 lines that I want. And it's going to name them with that name of the file, and it's going to add this tag here. Even though, if you do that, for you it's very clear. And here it is, correct? But for everybody else, it started to become difficult to read, because it's going to be a longer and longer and longer line the more things you add up. So this is why, please save your scripts as a different thingy. You can do that with Nano, and we can everybody be happy, because if, let's say, another student comes to the lab and he has to figure out what you wrote, it's going to be very, very difficult. But okay, let's say that we did this. So if I do cat, this file here, okay, I have 3 lines, fine. Now, if I want to remove everything, I use my wildcard, dot pdb dash midi dot txt. That should remove everything I don't want, and it's gone. And be very, very careful with that one because I cannot retrieve those files again. Yes?
You mentioned it, but how do you execute? How do you execute?
Ah, you already did that. Because if you remember this is the way. So yeah, so let's say we put this into a file. Nano. So for think in things, those things are going to be everything.pdb. Okay, we're going to take this out because it shouldn't be here. And let's create, I don't know, head minus n 5. And then the word done. Like that, it should be great. By the way, usually when you put this hashtag in the scripts, it means it's going to be ignored. Not in every single one of the different programming languages, but in Bash, in Python, yes, this is the way. Okay, enter, Control X. So if you do bash middle, then you have that. There is something inside of my script that is strange because it's complaining, like, what is this F command? I misspelled something or did something wrong in one of the lines. That's correct. Otherwise, it's actually telling me like, yeah, this is it. This is your thingies. And one is Cobain, the other one is ethane, the other one is methane, so on and so forth, in all the lists. Okay? So there you have it. Now let's go to a very good one that I like, the shell scripts. So finding things. This is actually very useful. And for that one, we're going to another KBL shell. Okay. So for that one, please go to writing, to this folder, exercise writing. Okay. Let's go, exercise writing. Let's clear the terminal and let's see. What do we have here? Okay. I honestly haven't read Little Woman ever. Like, it's not part of my education. I know it's a very good book and it's a very good novel, but that's just what I know. The other one is a haiku. So how do we see this haiku? Actually, it's a very good haiku. The Tao that is seen, well, you can read it, right? So this was, I think, from somebody of the carpentries make this. But anyway, yeah, it's already here outside. This is what we did so far. So there is one command that is very good that is called grep. Now you have here what it stands for. Grep is a construction for global regular expression and print. And as a matter of fact, it's one of the things that I like to use the most because it's very quick and it gives you what you want. The way I use it usually is like this. It's like, okay, I go to history and I pipe grep, and I don't know, I want to know how many times I use bash. And then I get a list of the times I use my bash command. I can do the same with head. And I use it even more. If I want to do something from this list, let's say 152, I just put exclamation mark 152 enter, and it will execute. But in this case, it will give me an error because I am not anymore with the fantastic creatures. Okay. Now, like I said, we have a haiku and we have little woman. How do you use grep? That's a very good one. Grep is very sensitive and it can be very powerful. For example, if we do grep and we just type HE, it returns the lines that have HE on it. For example, this one has HE here, this one here, this one here, and this one here. So it will go and search every single line, the pattern you want. Obviously, the shorter the pattern, the more lines you get. The more specific the pattern, less lines you get. Pretty straightforward. Pretty good for when you have something in the text and you want just to know how many times it appears. How do you do that? I know that in Little Woman, there is one sister called Joe, something like that. Is it a girl? I guess so. So grep, if you do, that's just Joe. And then Little Woman. Okay. There's a lot of lines to go. But it will, each of these lines have JO somewhere. You see? Answer Joe. Ah, I was right. Okay. Now, in how many lines of this text Joe appears? Very easy. You pipe grep with, imagine which command I'm going to use. Which command can I use to count lines? Word count. I can specify word count minus L to specifically count the lines. So the word JO appears 1,528 times in this text. So it took me about, what, 30 seconds, maybe? And then, you know, either you read the whole book or you just know the name of the sisters. I mean, you will not get the drama, but you can get how many times she is in the text. Yes, tell me. Yes, because it's in the same line. It's in the same line. Joe. Yeah, it counts one line. Ah, that's a very good. That's a good one. That's more advanced. As a matter of fact, grep can do that. You know, it's all the way onto the end of the lesson because it's here. You see, this command here has something special. That hat that it has, that dot and that O, is what is called actually expressions, regex in short. So those are telling like everything that starts with whatever letter and then an O, search for it. But that's an advanced topic for grep. So for now, we're going to stay with just simple. But if you are interested, you can get the same information from the carpentries. But really powerful, but also is very confusing. I cannot tell you how many hours I tried to master the regex expressions. But anyway, so going back to grep, you can do again grep. That's just help. And you can see you can go into a recursive mode. You can go into an inverted match, which is very good. As a matter of fact, you can use it. You can use this expression, these regex patterns that I was telling you about, but it's pretty complicated. Now you can do also minus W. Where is minus W? Where is my W? Here. So this one, for example, this will try to go for the exact match of the word that you are looking for. So if you do, for example, JO, or JO is different, right? But if you go and you put -W, it should go back. It goes actually lower because it's just trying to go for JO without anything at its size. So it's more precise to use -W. If you want precision, you use -W. Okay. Now, in the haiku, for example, I don't remember the metrics of the haiku, but cat haiku. Let's say if you want to find, or you want to find everything that is not with day, grep -b day haiku. It will get back all the lines that doesn't have the word day on it. Okay, sometimes you have to search for the pattern, or you know the pattern that you don't want. In this case, grep offers you both. And now comes the very interesting thing. I want you to find the names of the sisters of Little Woman. I want you to write a bash script that goes in with a for loop with the names of the sister, grep how many times those sisters appear in the text, and sort it. It's very advanced, but it's the closure. So again, please find the names of the sisters of Little Woman. I don't remember them. I just know Joe because it's very, very easy. Then in your script, you use grep to find the name of the sister. You use word count to know how many times she was actually called upon the lines. Okay? Save it as a bash script. Okay? Try it. Obviously, you have internet connection. You can find like who are the names of the sisters of this novel, right? Who doesn't have internet? Everybody has it. Yeah, perfect. Okay, thanks to Bart, I know that there are 4. Meg, Joe, Beth, and Amy. Small family. It's a wife? Yes.
If I've written the command I want to write it to the script, how do I do that? I use the arrow thing, but output that.
Okay, so you want to put something from the line, the command line, into the script. Excellent question.
Something similar like that.
Nice finding. Okay. In that case, my friend, use echo, then something. Now, the one arrow redirects the whole thing and writes it into the file. But if you use two arrows, then it appends it. Yep. So if you want to add something without erasing what was previously done, double arrow. That will append things. So pretty much everybody had this idea, right? Like you grab the name of the sister from that thingy, that's called little woman, and then you count how many times it appears in that text. Now, what I did here was to use something that is called relative path, because it doesn't matter where I am, as long as I know the full path to where I want to go, I can be in a complete different folder. Grep still is going to find the path towards that file. So it's very powerful. You don't have to be in the same place of your files. You can be in a complete different folder. There is that. And let's erase this one here. You can put the semicolons. As a matter of fact, what I do to match with what the command line shows me, I put here the semicolon, then here the semicolon, all the way here. The semicolon doesn't go with the done and the do. But that's, I mean, that's a matter of style. If for you is more clear, use it. Okay. So pretty much I can see that Amy is 643 times mentioned. Joe by far is the more mentioned. Even if we adjust for some errors, Bet is the less favorite, I guess. And Meh is about the middle. Okay. So you can pretty much tell who is this book about, right? Joe is like the star. Okay. So now you're almost about to master Bash, because if you are able to combine these things with a for loop, the pipes and the filters with the arrows, you're basically done with Bash. This is pretty much the core. You just need one more thing. That one more thing is how the hell I found something. Because so far we know where we are. As a matter of fact, Bash is that powerful that it can help you with your mental health. If you're ever wondering who you are, you can put, who am I? And it will tell you who you are, okay? That good. Now, it will also tell you where you are. In working directory, there you are, okay? You cannot get lost, neither you cannot find yourself. But you cannot find this way different files. For that one, you actually need the keyword find. So find is another command, really helpful. It has a lot of different usages. It has different forms. This one is a little bit different than other commands because it needs to tell you need to tell find search here where I want you to search and search for what. So it's very specific, it's very picky. This is why it was find, and then it's like, well, what do you want? Then the path where you want and what you want. So this part here is all the flags that you can put in front. The path goes before because it's like, where do you want me to find things? And then what? So to be clear, let's say that we are here. We are in at this level, shell lesson data. Sorry. If you do find, you have to tell him, okay, the path. I want you to find something here. And then you do minus type D. It will come back with only the folders. Because this is why it's very picky. Like, why the hell the option for folders is not minus F, right? Well, because you can also try to find files. And then with files, that's a different story. The type is F, right? So you can see here the difference. To find any folder inside of whatever folder you are, you can just put find here all the folders. And you have all the list of the folders. Find here all the files. And this could be a very, very, very long list of stuff. You can pipe it with grep if you know what you're doing. Grep, pentane, pent. And then it will tell you, okay, yes, here is where you have to go. You have to go inside exercise data, inside alkanes, and then you will find the file you asked. Okay? Find is very powerful and can be very precise. Okay? So instead of doing, for example, this piping, you can do pipe. You can do find minus name, and then the name of the file. Okay, I did something wrong. Yes, thank you. And I said chemistry is my strong. Thank you. So here it is. So you can find, like it was demonstrated just a moment ago, you have to be precise in what you want to find. So in this case, I had to write correctly pentane. If it not, it finds nothing. But then it's like find here the path and then the type or the name of the file that you want. Obviously, this can go over and over and over. You can do something like find inside, I don't know, this thing. Has to be in this thing here. This file here. Name, name, and it will find it. I mean, you can specify any path. It doesn't have to be where you are. Obviously, for this example, it works that I say find here in this folder because there is a finite number of files. But if it was like a huge number of files, like 6 million, 3 million, or whatever, then it could be really good that you have some kind of filter with grep, and then maybe it reduces to 1,000. And maybe 1,000 is already something that you can manage in a different way. Okay? So in this case, your next exercise is basically try to find little woman and try to find just all the folders again. In that case, once you do this, you're basically done with bash. Those are in these 2 hours and a half. These are basically all the commands that I can teach you that are the core of bash. Okay? So why don't you try to do, for example, a bash script that finds one of the different files that we have seen so far. You can even grep, you can do history, you can do all sort of things. Now remember, find can be type, can be name. Those are the most used ones. Those are going to be very useful to you. And the syntax is always first the path, and then what you want to find. Oh, by the way, everybody that is, everybody, once you're done, please, can you please fill out this form? Is the feedback form that we have for these tutorials, well, for these workshops. It will help me a lot to understand where I failed, where can I improve. What are your preference? It's here in the notepad, so feel free to fill it out if you want. Okay. All right. Take care. Okay. Yep. You're free to go whenever you want. So one last remark. Whenever you want, go back. Come on. Okay. So whenever you have free time, go back and read a bit of the material that we have, available for you in this software carpentry, because there are tricks that I didn't mention on purpose. Like, for example, there are many tricks that you can use to accelerate the scripts. There are some other uses of combining things, like, for example, all the way down here, there is this way of doing, what is it here? This kind of trick here is super useful when you want to find and count something really, really quick. And there are very few things that you can have in a notepad that you can just pick it up and use it every once in a while, just to accelerate how you work with your bash script. But go ahead and check it out. Okay, it's for you anyway, and it's open to everybody. Right? Okay, so your release of your software, you can go and have more coffee, because everything in here needs coffee. Okay, see you next time.